to find your calculator. You're going to hit second vars. Second vars. Okay, and then the one that you want to choose is the second one. Yep, so it's second function vars, and it's the second one here. The CDF, it stands for common distribution function. So normal, because it's a normal distribution, and then CDF, it's common distribution function. I haven't checked, but we'll see. Yeah. You liked it? All right, so let's go through this. Here's the question, and I know some of you still struggle with this one. Like, if you have two z-scores, one on the left, one on the right, could you calculate the area between those z-scores? The past 2 days, you'd have done area big, take away area small. Good. So you'd find the area for 2.31, right? And then you'd find the area for negative 0.85, and you would subtract them. Good. You would subtract them. So what we're going to do actually today is you're going to be able to skip that step, because you can do it on the calculator. So yeah, like you can do 2 times 3 on a calculator, right? But you still learn 2 times 3, right? Yeah. Okay. So the problem with the calculator is that you have to remember how to input the variables. Okay? That's the hardest part. Now listen up. Hey. If you got this one, it's actually a little bit easier. Okay, because this is the newer one. Now, take a look at the function that you have to do. So, you have to hit this normal CDF. Okay, so let's do this together. Second vars, normal CDF. Now on this nicer version of this calculator, it says lower, upper, mu, sigma, paste. Hands up, you got that. Hands up, you got that. Okay? So when I go through this, you just have to put in the lower and the upper where it says it. Okay? So we're going to be putting in, you're basically going to be copying this into your calculator. If you have the nicer one though, where it says lower, put the first number, where it says upper, put the second number. See if you can get that 0.79 to show up. Yeah, you have to put the comma, yeah. That's a good question. So normal CDF, and you can put the lower z-score first. That's the lower boundary, negative 0.85, comma, the upper boundary, 2.31. And the comma is right above the 7. So there it is. You guys can handle that? Okay? So that's if you have the z-scores. If you have the z-scores. You can also do this if you just have the actual values. You just have to do a couple more inputs. Okay, so let's go to that. Okay, so this is what's going to confuse some of you. Hopefully we can figure this out. And I'll just draw it on the whiteboard. This is going to be a little bit weird. You see this curve? It actually goes on infinitely forever like this. And it doesn't actually touch the horizontal, it doesn't touch the x-axis. So it goes on forever. So when you have to do a lower boundary and an upper boundary for like really, 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 really small and really, 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 really big, you can use these values here. 10 to the 99 and 10 to the negative 10 to the 99. Okay, so it's really big, 10 to the 99, like it's got 99 zeros after the 10, like it's really big. This one's positive, and of course this one is negative. So really, really, really small and really, really, really big. You can put that in there in your notes if you like. Question? Yours is weird? Okay, hopefully we can figure it out then. Okay, so let's try some of these. So this question we did yesterday, if you guys might remember this. Let's just quickly read it. It says, so a study showed that the mean duration of a flu virus is 12 days. So 12 goes right in the middle. You guys remember this? 12 goes right in the middle. And it says the standard deviation is 3 days. So one deviation to the right, it'd be at 15. One more deviation over, it'd be at 18. One deviation left, it would be at 9, and one deviation left more is 6. So what's the probability that this is going to last longer than 17 days? Find 17 is probably somewhere to the right of, yeah, somewhere here, right? So that would be 17, and then you can shade to the right. Why do we shade to the right? Because it's longer. Good. So how would you put this one in the calculator? Look at the bottom of the page. Okay, so you're going to hit the normal CDF. Do this with me. Second function, vars. Second function, vars. And then it's the number 2 option, normal CDF. Now, for this one, what was the lower bound? What was the lower boundary? What's the left boundary? 17, and then you want everything to the right of 17? So you need 17's the small side on the left, and then you have like infinity on the right. So you can use your book to help you. 17 is the lower bound, and then you just need a really big number for the upper bound. So that's why it's 10 to the 99. Like, I'm sure it'd still work if you put like, I don't know, a million or something. But 10 to the 99 works. So it's 10 exponent 99. Now it says comma 12 comma 3. Why do you think you have to tell the calculator 12 and 3? 12 was the average, and 3 is the standard deviation. So the first one is mu, and the second one is sigma. And see if you can get the same value as the calculator. You're able to get it? Okay, good. Now what about the next one? It says between 13 and 15. So between 13 and 15, you'd have to find 13 and then shade into 15. So now I'm okay. What would the area be from 13 to 15? It's this blue section. How would you do the blue section? Well, this one's actually easier because the lower bound is 13 and the upper bound is 15. So you don't have to do anything special. You just go here. That's what you'd put into your calculator. 13 comma 15, lower bound comma upper bound, and then you put in the mean and then the standard deviation, and it'll pump out the area. This area, this 0.2107, that's 21.07%. What does that represent? That represents the probability that your flu will last between 13 to 15 days. That's the whole point of these statistical analysis. is to understand like, okay, so what are the chances of this happening? There's about a 20% chance that your flu is gonna last 13 to 15 days. Okay, so I think we have enough in our toolkit to actually solve a problem on our own. Okay, so this is a post office. They send mail. Let's highlight the average. Right here it says average, top right. Highlight the average. What's the average? 3 weeks. Reading through it, blah, 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 blah. They also determined that the standard deviation is 5 days. Now you got to be careful here. The deviation's in days, the average is in weeks. You got to be consistent. So let's just change the average into days. 3 weeks is how many days? 21 days, right? 3 times 7, 21. And then you got sigma here is 5 days. You guys okay with that? Okay. Now, what I recommend is that you don't just go pumping into your calculator. Like, I would recommend that you sketch this out onto your chart. And I'll provide these charts for your exam, so you don't have to like sketch these curves. I'll provide these curves for you, so you can just write on top of them. So if 21 is the average, what's one standard deviation to the right? 26, because it's 5, right? Each deviation is worth 5. The next one would be 31. Good. Go to the left, you'd have 16. One more over to the left, you'd have 11. Now let's go and try to answer the question. Like, what do they want? They want probability that a package will take less than 15. So find 15 approximately. That looks like about 15. And then which way do we shade, you guys? Left. Very nice. All right, so then you go normal CDF. What's the lower bound? It's like negative infinity, right? How do you write negative infinity on your calculator? You got to just write a really large number. And then what's the upper bound? 15. What's the mu? 21. And then what's sigma? 5. And then that just pumps it out for you. You don't have to use the chart, actually. Okay. You don't actually have to use the chart. Whoops. Okay, relax, my friend. Okay, negative 10 to the power 99, comma, upper bound was 15, comma, average 21, comma, standard deviation 5. You guys get that? All right. So staring at this decimal, move the decimal twice. How much percent is this? 11.5%? Now, just be careful. What do they want? The probability to the nearest hundredth. Okay, so 0.115, but they wanted to the nearest. So if you just leave it as a decimal, it would be 0.12. Because the 5 would round it up. Correct. Correct. Whoa. There you go. Okay, the post office here is going to say, okay, we're going to guarantee that if the package arrives less than 35 days, or the delivery is free. So it's going to come within 35 days, or otherwise you get it for free. Last month, about 8,000 packages sent from China. How many of these packages would you expect to be delivered free? All right. So right now I'm thinking to myself, how about I just get it down on the chart? 35 days. Where does that go on my chart? Just past 31. So it's over here somewhere. There's 35. Now, it says it's going to be free if it's not delivered less than 35. So if it's longer than, it's like when you order a pizza. If it doesn't come in 30 minutes, it's free. Only on TV, I think. I think it's just Domino's, right? I think it's Domino's. Used to. Yeah. Yeah. Good. So for this 35, like, do we want to shade before the 35 or after the 35? Yeah, after, because it's the ones that come late. So after 35, those are the ones we're interested in. Is that a really big area I shaded relative to the whole? So you should predict, or you should see a small value when we do this. Okay, so when you go to do the normal CDF, the lower bound is 35. Because we're starting at 35, and then we're going to shade all the way to like a really big number, so positive 10 to the 99. And then you can put in the average and the standard deviation. Did you guys get that? So this calculator spits out this answer. Now, you got to be careful here. This 0.002, what percent would that be? Good, 0.2%. It's not even a full percent. That way they can think to themselves, it's not even a full percent will be delivered free, so we're good. Like we're not going to lose that much money. Okay, so what was that value again? 0.0025? Okay, but that's not what they're asking for. They're not asking for the probability, are they? They're asking for how many packages. So, you take this and you times it by the 8257. Very nice. Okay, can you guys do that for me? Did you get roughly 21? So 21 packages will not be charged. They're going to get delivered for free. 21 packages are sent for free. Okay, let's take a look at this one. This question I don't really like because they don't really give you anything. Do they? Calculate the percentage of the population to the nearest tenth whose height is more than one standard deviation above the average. So the one thing that this question should have, it doesn't have, is that heights are normally distributed. This is true. Like, what's the average height of a male? What's the average height of a female? Like, those are pretty well known statistics. Okay? So, in terms of you guys in this class, you would, hey, listen, you would be told heights are normally distributed. Oh, okay, now I do this normal distribution type of work. Like, you have to be triggered what math am I going to do? The normal distribution tells you, okay, I got to do the work on the curve here. Okay? So what is one standard deviation above? One standard deviation above. What would that look like? Zero's in the middle. Just one above? Yeah, you already know that one, right? Okay. So what you can do now is go normal CDF. And if you have the Z scores, you just have to put them in. You don't need the mean or the standard deviation if you have the Z scores. So second vars. So you get 34, 0.3413. Now in your workbook, I just want you to flip back a few lessons. Flip back a few lessons. Go to page 222. 222. You guys have been doing a lot of work recently. I wonder if you've forgotten about this picture. Page 222. Remember we talked about the normal distribution? About 34% of the population is one standard deviation above the average. Here's my question for you, and Olivia, you don't get to answer. How much of the population is within one standard deviation, either way? Yeah, 68.26. Right, Parker?
Yes, sir.
Okay. How much of the population's within two standard deviations? That means you have to add up 4 columns, right? Yeah. So you'd have to add up about 68 and about 27, so about 95. Okay. So I think you guys have enough at your disposal. Let's see if you guys can try questions 1 through 4. And then I'm going to give you the quiz from yesterday's lesson as well. So you got assignment questions 1 through 4 and yesterday's quiz before the end of the block. And listen, last thing I'll tell you. You can now start to use normal CDF for the stuff we were doing yesterday. That's okay. You don't always have to use the chart if you don't want to. But the chart is always acceptable as well. Okay, so you're on page 246, and we're going to be working backwards now. We're going to start with the area and then get the Z scores. This one's going to be called INV norm. INV norm. So it's like inverse normal. It's like reversing the process. Okay? So in this case, you have to put in the area, and then it's going to spit out the Z score. Okay? So like this question's saying 8%, so highlight it. They're telling you that 8% of the toasters that are sold, we did this question yesterday, the company doesn't want to replace under warranty more than 8% of the toasters. So we have to find the Z score for 8%. Okay, 8%. So take a look at how you enter this in the calculator. You go inv norm, so it's the same place, second vars, it's number 3 on the list. And then you have to put in the area and then the average and the standard deviation. Just like down here. So you just put in the area as a decimal. So that 8% you have to put in as 0.08. And then you put the average and then you put the standard deviation. All right, so this is going to spit out 3.3 years. Okay, and we talked about this yesterday. The company rounds down and they're going to offer the 3-year warranty. They're going to offer the 3-year warranty. Okay, so let's do one all on our own. Class example 3. This one they're just going to ask us to find the z-score. So it says determine the z-score to the nearest hundredth if 1% of the data lies above the z-score. So that's going to be way out here, I believe. Because it's only 1% above. 1% above. But that z-score, if you remember back on the chart, the z-scores always calculate the area to the left. So when I put this into my calculator, I can't put in the 1%. When I do this calculation, I'm going to go inv norm, and I'm going to go 0.9901. Because the z-score is for 99% of the data to the left of it, not the 1% above. Okay? And then why do I have 0, 1? Because for normal distributions, the z-score is 0 for the average and has a standard deviation of 1. 0 and 1 for the normal distribution. Okay, so I go second vars, inv norm, and then it says area. I'm going to put in 0.9901, paste that in there. I got 2.33. Not bad. Let's go jump to question 5. Let's do question 5 together. So the rest of this assignment now. And you'll have time to finish this off tomorrow as well as the 2 quizzes. So tomorrow will be this assignment and the 2 quizzes. You'll have a sub in tomorrow. Okay, let's do number 5 together. Page 249, let's do number 5. Okay, a manufacturer does a study on the photo radars they produce and find that they have an average of 16.3 years. And the standard deviation is 4.2. And then this is a tip, right? If the data is normally distributed, then we can use our knowledge of normal distributions to solve this problem. So what guarantee to the nearest necessary year should the manufacturer give so that fewer than 9% of the photo radar units would be returned? Fewer than 9%. So they're giving us the area. Your given area, which is 9%, and you'd have to switch that to 0.09. And then you can do this inv norm of 0.09. And now you have to put in this mu and then the standard deviations. So the average is 16.3 and the sigma is 4.2. Okay, I got 10.66, so I guess this would round to 11 years. Okay, so they're saying that the average radar detector lasts for about 16 years. The calculation shows us that about 9% of those photo radar equipment would only last about 11 years. About 9% will last about 11 years. Okay? So now you can go both ways. You're given the z-score or the data values, you find the area. Okay? That's what we started class with, normal CDF. Or you're given the area and you work backwards using the inv norm, inverse normal. Okay? So you guys can maybe try 5b and number 6 before you leave. And I just checked the answer book, so not 11 years. They want you to round down. They want you to round down to 10 years. Round down. Because the 9% doesn't actually make the 11th year. So they want you to round down. Yeah, that's a good. She's saying that's like if you're making cookies and you have enough batter to fill, like, you know, they're all the same size cookies, but then you only have enough batter left for like half a cookie. You just got to eat that batter. Oh yeah, muffins is batter.